Hello friends, welcome back to Code with Roy. Today we'll be learning a Spring Boot topic called Service Registry. This is very important in Spring Boot. We everyday use it, but sometimes we do not know very in details about this particular thing, how it works. So today we'll be learning this one in depth. There will be a theory section, so that will be the part one of the video, and the second part will be doing the practical to see how hands-on it works. So without any more time, let's start. What we'll be learning today? First thing is what is service registry, then key roles of service registry, why do we need service registry, types of service discovery, service registry in Spring Boot, service registry lifecycle, and then we'll see some example how it works. So what is service registry? In microservices architecture, services are typically small, independent, and run in different host ports. So say we have, let me give you an example, say that we have a order service which actually provides order, and then we have a payment service. So let's think about a small scenario that after order we have to do a payment. So these are two individual microservices. Now what in real world what will happen, we cannot have only one instances, right? In production environment we'll have multiple instances of both order services and payment services. Dynamically, how do we know in which host and port each services are running? We cannot know dynamically, right? Means in real world we can hard code it, but that won't work. Means that will work in a local host probably, but not in a production environment. So that's why this service registry come into picture. So service registry is a central directory that keeps track of all active services instances and their network addresses. So you can think like it's a phone book for microservices. So whenever we are spawning a new uh, instances of a microservice, service registry will add it, and we can get that particular host port from service registry. If we call the service registry, it will give us. If something is going down, it will automatically remove from service registry. So next, go to the next slide and see key roles of service registry. So what are the key roles? So each microservice registers itself with the registry when it starts. So each microservice, it will register itself with the service registry. Say this is a catalog service. When we will run or start this catalog service, it himself, or it means it itself, it will register with the service registry. So these microservices will be available in service registry. If we call catalog service, service registry will let us know that okay, this catalog service is now running in this host and in this port. Then the second key role is service discovery. So a client, say order service, right? Order service is asking the registry where is the catalog service. So service registry discovers. So that is that service discovery part of it. So it will discovers and it will tell us that okay, this is the host 10.0.1.5 and port is 8080 where this catalog service is running. So the second thing is service discovery. Third one is health checking. So service registry always keep checking the health of each of the services which are registered with it, and then if it is not responding, means if health check response is failed, it will remove that instance from the service registry. So these are the three important things happens in service registry. One is that registration of the services, second one is the discovery of the services, third one is the health checking. Why do we need service registry? Without a service registry, you would need a static IP DNS, as I said, right? It's possible without a service registry, but that's only in a local machine. But in production environment, without service registry, we cannot have any clue where the services are running. Next is with the service registry, dynamic discovery. So the benefits which we get through a service registry is a dynamic discovery. So we know we do not need to hard code any host name. Load balancing, it will automatically load balance, means if there are multiple instances, it will know which instance to provide. So it will do the load balancing as well. Fault tolerance. Fault tolerance means if some of the instances, say payment service has 4 instances, all of a sudden because of any hardware issue, one of the instances are down. So it will automatically remove it from the service registry. So it will never give that in the down instance to a client. So that is the fault tolerance. Scalability. Now there are more, since it's running in AWS. Say payment service is running in AWS, and there are more. It needs to spawn a new instance. So it will automatically spawn AWS will automatically spawn a new instance, and then automatically when that new instance is spawned, it will register itself with the service registry. So that's how the scalability part will be covered. Types of service discovery. So we learn it discovers services, but there are two main mechanisms rather, through which it discovers services. One is client side discovery. So the client side discovery is the client requires the registry, sorry, client queries the registry and chooses an instance. So in this scenario, client will directly call the registry service, and it will get the host and port of the service, and it will call it. So that is basically a client side discovery. Client does everything. All the headaches are with client. So that is client side discovery. We'll be seeing in detail this client side discovery and then server side discovery in next slide. And disadvantage is every client must implement discovery logic. So now for this one, since client is doing everything, there may be 40, 50, 60 clients, right? Means each microservice is basically a client. So if we use this client side discovery, we have to put all the logics inside each client. So that is a disadvantage, and that is why in prod environment or in real environment we do not use client side discovery, rather we use server side discovery. So what is server side discovery? Server side discovery, the client sends a request to a load balancer. So all the logics, instead of having all the logics in each client, here we put all the logic in a load balancer or API gateway in a single place. So this gateway queries the registry. Now whatever in client side discovery, whatever client used to do, all those roles are now with this load balancer or API gateway. So that will queries the registry, that will select an instance, and that will forward which instance to be invoked. Example, AWS Elastic Load Balancer, ELB, Kubernetes services. Advantages, client is simpler. Disadvantages, registry or gateway does more work. Now let's see in details client side discovery, how it works. So in client side discovery, the client is responsible for querying the service registry, selecting an available service instances through load balancing, sending the request directly to the chosen service instance. So all these three things a client does for client side discovery. How it works? So say a service instance order service registers itself with service registry. So here client side service registry, say we have Eureka. We can have this console or Zookeeper as well. So say we have this order service which registers itself with Eureka, and then there is another client, uh, say payment service, wants to call order service. It requires a registry. So now say order service wants to call payment service, think like that, and then what it needs to do, order service will call Eureka and check if that payment service is registered there. It will get the host port information from the Eureka, and this payments order service itself have to call this payment service. So this is a client side discovery. The client gets a list of available instances and then it's called that particular instance. So this is a client side discovery. Advantages: no extra hop. So there is no separate load balancer or API gateway. So no extra hop, it will be little faster. Client has full control and flexible and scalable for lightweight systems. So as I said, right, in a small system or in local machine, this is possible. The disadvantage is huge, right? This disadvantage is huge. Client complexity increases. We cannot keep writing the same logic in each client, right? The registry logic and load balancing code we have to put in each client for this client side discovery. If many clients, each must implement discovery logic. Updating all clients if registry API changes. Tight coupling. Yeah, so now another thing, right? Means if some registry information changes, say we change that payment service to payment gateway service or something like that, right? Then we have to update every client. So that is a disadvantage, big disadvantage. So in contrast with the advantages, disadvantages are huge for client side discovery. So example, in Spring Cloud, Eureka server as registry, Ribbon or Spring Cloud load balancer as client side. So these are the examples. Now server side discovery. In server side discovery, the client is not aware of service registry details. Instead, client sends request to a load balancer or service gateway. So now we are detaching all the logic from client and putting all those logics in a separate single place, which is a load balancer or service gateway, means API gateway. So the load balancer queries the registry, picks healthy instance and forward the rest. So whatever each client was doing, now we are doing it in a specific place, which is a load balancer service registry. How it works, same thing, services registers with service registry. The client makes a generic request like this one, orders mycompany.com. Load balancer, it may be AWS Elastic Load Balancer, HA proxy or API gateway or APG or Zool, anything. So we can, if we implement these things in your project, HA proxy or APG or Zool, then you think you have a server side discovery. And basically any real-time project has server side discovery. The request is routed to the chosen service instance. So this is how it works, I mean the steps. I hope you understood this much. Next, the advantages. Advantages are huge. Client remains simple, no discovery logic. So client doesn't have to have all these logics. Easy to replace, upgrade, discovery mechanism. Since it's in one place, we just need not to write it in multiple places or update it in multiple places later on. Better for large scale distributed systems. Disadvantages, this is a small disadvantage in terms of or in comparison with the advantages it gives. So extra hop is instead of client was directly calling to the service, it is calling a load balancer and load balancer is doing all the work. So load balancer becomes a single point of failure if not highly available. Yeah, means so the only another disadvantage is if something happens to the load balancer, everything will be down because everything is relying on a load balancer for now for each of their discovery services. More infrastructure complexity, need to maintain smart gateways or manage services. So examples, AWS Elastic Load Balancer, Kubernetes, etc. So this is in a tabular format, all the differences between these two. So discovery responsibility for client side discovery, it's with client. For server side discovery, it's with load balancer or the gateway, API gateway. Load balancing done by client through ribbon or spring cloud LB, and for server side it's done by load balancer like ELB or whatever it is. Client complexity higher because all the logic needs to be, all the registry logic needs to be inside the client, and here it's lower, no logics need to be added in the client. Extra hop, there is no extra hop. For server side there is one extra hop because it has to go to the load balancer. Scalability, good for small or medium systems. Basically I don't think it's even good for medium system, it's only good for small, very small system. And server side discovery based for large scale cloud native, means real time scenarios, we always need to have server side discovery. Examples, Netflix. So client side examples is Netflix, OSS, Eureka plus Ribbon. So basically Eureka, we'll be seeing it in our example how we are using Eureka. And for server side discovery we have AWS, ELB, Kubernetes, APG, Joule, etc. Popular service registry tools, we have Netflix Eureka. This is widely used. Then we have Console, we have Apache Zookeeper, we have Kubernetes, we have etcd. So these are the examples of service registry. Now we'll see some examples how it has been implemented or how it works in real world. So service registry in Spring Boot. In Spring Boot world, the most common registry is Netflix Eureka, and we'll be doing some programming with Eureka in next second part of the video. How it works? So Eureka server. So we have to create or we have to write one Spring Boot service which we have to dedicate to Eureka. How we will do that? We'll be showing soon after means in our second part of this video. But that Eureka will be running on 8761, that is a default port for Eureka. So when we'll be running that Eureka server, it will have a heartbeat, it will monitor all the services which will be registered with Eureka, say catalog service. So when another service will call catalog service, it will come to Eureka and Eureka will provide the host and port. So Eureka will check what all host and ports it's running, and then Eureka will provide that host and ports for that calling service. So this is the example flow. Catalog service registers as catalog service with Eureka. Order service makes a request. So order service makes this call and it will come to Eureka. Eureka will check where this catalog service is registered. So Eureka will return, say we have two instances running for these catalog services. One is in 10.0.0.5 and second one is in 10.0.0.8 and in port 8081 and then 8083. So when order service will call Eureka, Eureka will return these two instances, and then whatever load balancer, means inside the catalog service how we want to write it, it will pick one instance and it will invoke catalog service. So service registry lifecycle, instance startup, service registers. So whenever a client starts up, it registers itself with Eureka. There is a heartbeat which Eureka always monitors that service is live or dead. Then there will be a discovery when a call comes to Eureka. Eureka will provide the instance of that service. If the service is not responding through a heartbeat, eviction will happen. It will remove that instance from the registry, and service if shutdown, during shutdown, services deregisters gracefully. So if we shut down any of the services, it will automatically deregisters itself with Eureka. Now for Eureka, we just need one dependency. Means we can turn any of our Spring Boot services or microservices into Eureka just by adding this dependency and one entry in YML, which I'll be showing. So we just need this dependency in POM. The dependency is Spring Cloud Starter Netflix Eureka Server. This will change our Spring Boot microservice or Spring Boot service to a Eureka server. Okay, so this is that dependency for Eureka server. This is a dependency for Eureka client. So all other microservices which we want to register to Eureka, we have to make them Eureka client. So we have to add this dependency to those microservices. So the microservice or the Spring Boot service which we want to turn into Eureka server, we need this dependency, Spring Cloud Starter Netflix Eureka server. The others which will register itself with Eureka, they should be having this dependency, Spring Cloud Starter Netflix Eureka client. Main application, so this is the Eureka server which we need to annotate with enable Eureka server. So first of all that dependency, second of all we have to annotate it with Eureka, enable Eureka server. And third thing is we in application.yml we have to add this entry Eureka client register with Eureka false and Eureka client fetch registry false. Means this, if we don't do this, it will automatically try to register with itself because this is a Eureka server, right? If so, here what we are saying is Eureka client register with Eureka false. So I'm saying it, you don't register yourself with Eureka and you don't try to fetch yourself from Eureka. So these are the two components which we have to add in our application.yml or application.properties. And then the default port is basically 8761 for Eureka, so we can run it in 8761. Now the client we don't need to do anything. Client will be a normal client and that's it, right? Client will automatically register with Eureka. So this is a client example. Okay, so client we need to add basically this one, Eureka client server URL default zone is Eureka. So by default it will register itself with Eureka. So this is a catalog service which is running on 8081 port, and with this entry Eureka client server URL default zone http://localhost 8761 Eureka, it will register it with the Eureka. So this is a sample example uh, how we are calling using Eureka load balancing and then calling using a REST template. So this is the app config where we are having a REST template. I'll be doing these things in hands-on. So means if you think it's complex and it's not properly demonstrated here, please wait for the next video and there we will be doing hands-on for all these things. But just to explain, this is the order service which is basically checking in Eureka. So if you see here, this REST service call is saying http:// service products product ID. So this what it will do, it will connect to with Eureka with this name catalog service. Eureka will provide the instance for the catalog service and then it will invoke that catalog service instance. So this is basically happening here in order service. So final solution with this setup runs Eureka server. Eureka we are running on 8761, catalog service we are running on 8081, which is registers itself with Eureka, and then the order service which is discovering catalog service by name, and then it will invoke catalog service from order service. So this is it for today. Just wait for the next video where we will be doing the hands-on, and there will be showing you how this works and how we can implement them. Thank you so much. Have a nice day ahead.